In this video, we're going to turn this 16-pound block of titanium into an aerospace part that weighs just half a pound. The whole process takes about 10 hours of machining and requires 4 different operations. So let's get right into it. First, we clamp our raw stock into our VF-2 using a standard 6-inch vise. Since we're going to remove over 90% of material, we'll start our roughing operations with a 1/2-inch 5-flute end mill at 2,000 RPMs at about 25 inches a minute. The reason we cut titanium so much slower than compared to aluminum comes down to its mechanical properties. Titanium is extremely strong, which is beneficial for us. We can machine thin, complex geometry while maintaining tight tolerances. If this part was made of aluminum, it would be much harder to hold its geometry without distortion. While making this part, we're continuously running coolant to prevent the tool from overheating and recutting chips. Because of the geometry, we're essentially making a bowl. If we don't run coolant, chips will eventually pack in and break our tool. With Op 1 complete, we flip the part over in our vise and use the same 1/2-inch end mill for our roughing operation. When removing this much material in the part, you really need to stress relieve it, which is what we do in our first and second op. If we didn't stress relieve this part, we would never be able to hit our flatness callout. Now that we're done with Op 2, we'll move on to our custom fixture and hold it down. After roughing out the remainder of the pockets, we finish the core of our part with a 3/8 bullnose end mill with a 20 thou radius. Once the center is complete, we can switch over our toe clamps on the side and run bolts through the middle. That frees the perimeter so we can finish the outside features without losing clamping force. At this stage, there's very little roughing left. We're mainly going to focus on finishing. And now we move on to the final fixture, where we're going to finish our top face and drill and tap some holes. Lastly, we finish the remaining geometry, add some counterbores, and deburr the edges with a lollipop end mill. And this is the final part. It's deceiving because of how light and thin it is, but it maintained its structural rigidity while passing all the tolerances on the print. So if you like this video, subscribe to our channel.